Okay, so we're on unit 9.6. Okay, unit 9.6. Like I said earlier, we're going to work on the last set, or we're going to work on the last shape today. So we're going to find vertices. So yes, that's multiple vertices, so there's going to be two. Vertices and something called asymptotes. Asymptotes is spelled A-S-Y. I just spelled it wrong. A-S-Y-M-P-T-O-T-E-S. Asymptotes. Okay, vertices and asymptotes for a hyperbola. A hyperbola. Not a hyperbole, because that's in English, but a hyperbola. Okay? There are two different formulas that you are going to have to memorize for a hyperbola. The first one is x minus h squared over a squared minus y minus k squared over b squared equals 1. The only difference between a hyperbola and an ellipse formula is that there will be a negative in between. Okay, an ellipse has a plus, a hyperbola has a minus. Now, you also are going to have to memorize another formula for a hyperbola. Okay, sometimes they start with x, but hyperbolas can also start with the y part. So y minus k squared over a squared minus x minus h squared over b squared equals 1. These are both, they're basically essentially the same. Okay, the only difference is which is positive. If the x's are positive, so if the x comes first and it's positive, that means that the hyperbolas basically look like parabolas, but there's two of them. Okay, if the x is positive, that means that it's going to go side to side. So they're going to open up side to side. They don't touch each other ever, but they're going to go side to side. If the y is positive, it means that they will go up and down. They will open up and down. And they don't necessarily touch each other. I drew those really close, but I apologize. They don't necessarily touch each other. So the formulas are essentially exactly the same. It just depends on which one comes first. That'll tell you if it opens up or down. Okay, if the x's are first, I generally call them what's called an x-hugger. Okay, they hug the x-axis. They go around the x-axis if you put an axis in there. If the y's are first, I would call them a y-hugger. Okay, they wrap around the y-axis. And that's how you can tell which way things open. So, for your examples, we're going to ask you to find the center, vertices, and sketch. Find the center, the vertices, and sketch. So, for example number 1, if I give you the equation x squared over 4 minus y squared over 9 equals 1. X squared over 4 minus y squared over 9 equals 1. So the first thing you're going to do is find the center. Okay? Center comes from the same place it always does. If you have parentheses, you just change the sign of whatever's in the parentheses. Since there are no parentheses here, where do you think the center is? 0, 0. Okay, so we're going to draw a sketch. Your center will be at 0, 0. Just make a dot. Now, just like an ellipse, the x movement, okay, the x, how much you move on the x-axis, which is side to side, comes from the square root of the x denominator. So the x denominator is a 4. If you take the square root of that, how far do you think you'll move side to side? 2. So that means you're going to move right 2 and left 2 and make a dot. The y denominator is going to tell you how far you move up and down. So what's the square root of the y denominator? 3. So that tells you you're going to move up 3 and down 3. And make a dot. Now, yesterday with an ellipse, we simply connected the dots and it made an ellipse. Today we're going to do almost exactly inverse of that. What you're going to do is I want you to make a dotted line box that goes through all of these. Okay, make a dotted line and make a box that's going to go through all of these. This is not actually part of your graph, so that's why we're making it, trying to make it really faint. Then, once you make a dot that connects all 4 edges, okay, you're going to make a line, and the lines are actually going to go from corner to corner and through the center. So we're going to make lines that go straight through each side. So we're going to make kind of like a giant X. These are called asymptotes. Okay, asymptotes are basically just guidelines for your hyperbolas. It's going to tell you if they're going to be really skinny or really wide. Once you've made the asymptotes, and these are basically just guidelines, what you're going to do is whatever letter is positive, so in this case the X, this tells you it's going to be an X-axis hooker. Okay, X hyperbolas, if it's positive X, which way do you think they're going to open? Side to side or up and down? Side to side. Okay, so they're going to go around, they're going to wrap around the X-axis. And you're going to follow these on the edges. That's exactly how wide they're going to get. So the actual answer here is the hyperbolas. Okay, it has nothing to do with the asymptotes. That's not part of your answer. Okay, the actual graph is just the hyperbolas. Then your answer part, looking for the vertices, you actually have to label these points. So the points are right here. Okay, we don't make they don't start from 0, 0, but we make your hyperbolas based from these vertices. So what is this vertex if you labeled this point? What point is that? Is this 2, 0 or 0, 2? 2, 0. So that vertex is at 2, 0, and this vertex is at what? Negative 2, 0. That is your answer. Okay, and once we do more of these, it'll become a little bit easier. Questions so far? If you missed ellipses, this is probably a little more confusing. Okay, let's try another one for number 2. Okay, same thing. I'm going to sketch, find the center and the vertices of y squared over 16 minus x squared equals 1. Y squared over 16 minus x squared equals 1. First thing we want to do is make sure this is in standard form. What's missing as far as the x goes? The denominator. So what does the denominator have to be? A 1. So you can write it over 1. You don't have to, but you can if it helps you. Then you can find the center. What's the center of this hyperbola? 0, 0. There's no parentheses, so it has to be at 0, 0. When we draw this, your center is at 0, 0. How far out on the x-axis should you move? How far out on the x should you move? I heard 1 and I heard 4. Okay? Make sure that you're following the right denominator. The x denominator is second here. So you have to take the square root of the x denominator to tell you how far to move side to side. This is 1. This is why these shapes are a little bit difficult for people, is because they don't look at which is x and which is y. They just automatically do x first, then y. So you have to just make sure and you're kind of paying attention. So square root of the denominator told you to move 1 left and right. How far should you move up and down? 4. Okay, so move up 4, down 4 from the center. Okay, and it's not always going to be at 0, 0. It's really nice when it is, but they're not always going to be there. Then connect your dots with a dotted line box. Then draw in your asymptotes, and the asymptotes basically go through the edges of the box and the center. And these are going to be your guidelines. And then which way will the hyperbolas open on this equation? Up and down or side to side? Since the y portion is positive, since the y is first, it's going to wrap around the y-axis, which is up and down. So these are going to go, they go just to where they meet your asymptotes, up and down hyperbolas. You also have to label your vertices. So what vertex is this? What point is that right there? Over 0, up what? 4. Over 0, up 4. And over 0, up or down, negative 4. That's your answer. Questions on how I did that so far? So is this fairly simple? Is this difficult? It's a pattern. You have to follow the pattern. Okay, let's try another one for number 3. Again, I want you to find the center vertices in sketch of 16y squared minus x minus 3 squared equals 64. 16y squared minus x minus 3 squared equals 64. First thing you see here is what? What's wrong with this equation? There's no denominators, and it's equal to 64. I need this to be equal to 1. So how am I going to get it equal to 1? What do I do with the 64? Divide. Divide every single part by 64. Okay, divide every part by 64. 16 over 64 is going to leave you y squared over 4 minus x minus 3 squared over 64 equals 1. From there, you can find the center. What would the center be of this hyperbola? Nope, not 0, 3. X part has to go first, so you have to pay attention to which is x and which is y. It's not always going to be x first, then y. So just pay attention. So 3, 0. And remember, you're changing the signs for each one. Make your center at 3, 0. So is that over 3 or up 3? Over 3. Okay, so over 3. Make your center. How far did you move side to side? 8. Take the square root of the x denominator, so that tells you to move over 8. So 8 in the right direction, 8 in the left direction. Make your dots. Now remember, we're moving from the center, not from 0, 0. Okay, so be careful. You're moving from this 3, 0, not from 0, 0. And then how far should you move up and down? 2. Okay, so from the center point, you're going to move up 2 and down 2. Be careful that you're making your points from the center, not from 0, 0. Then make that dotted box. Okay, your asymptotes will go straight through the edges and through the center. Make them as straight as you can. They don't have to be perfect. Do the best you can. And then will these hyperbolas be opening up and down or side to side? Up and down, because the y portion is first. Okay, so these are up and down hyperbolas. Question, oh, and then, I'm sorry, also label these points. So this vertex is at what? What point is this top one? Over 3, up 2. And then the second one is over 3, down 2. Questions on how I did that? Yes? Question? Just stretching? Okay. Simple enough, hopefully? Okay. Excuse me. Next thing we're going to do is just changing things to be written in standard form. So write in standard form. Pretty much anytime we're going to ask you to write in standard form, there's going to be some completing the square involved. And we've been doing that for the past couple days, so it should be fairly simple for you. So write in standard form. If I give you the equation, 16x squared minus 4y squared minus 96x minus 16y plus 64 equals 0. 16x squared minus 4y squared minus 96x minus 16y plus 64 equals 0. Anyone recall, how do we write things in standard form? What are you going to have to do first? Get the x's together first. So we're going to have to group things together. We're going to get the x's together. You're going to get the y's together. And what do you do with that number that's kind of by itself? Move the number to the right side. So get the x's together, get the y's together, move the number to the right side. So we're just going to rearrange. So 16x squared minus 96x negative 4y squared. Make sure you take that negative with it, minus 16y. And then when you move the 64, it's going to become negative 64 on the other side. What's my next step in completing the square? Take out that a value, so take out the values attached to the squares. So take out a 16, left behind would be x squared minus what? 96 divided by 16 gives you what? Six. Leave your space still. What are you going to take out from the y's? Negative 4. You have to take out whatever sign is attached there. Then left behind will be y squared. Negative 16 divided by negative 4 leaves you a plus 4y. So make sure you're careful with your signs there. And then negative 64. To complete the square, you're going to take the middle number, which in this case is negative, divide it by 2 and square it. So negative 3 squared, what am I going to add in with the x's? Plus 9. What do I add to the opposite side, though? You have to add 16 times 9, which in this case is 144. Okay, remember, you have to multiply back through. For the y's, take that middle number, divide it by 2 and square it. So 2 squared, what am I going to add inside with the y's? 16 times 9.
Oh.
What do I add inside with the y's?
4.
Plus 4. And what do I add to the opposite side?
Plus 16.
Negative 16. Okay, you have to factor, or you have to multiply through by that negative, so minus 16. Then when we rewrite these as perfect squares, you have 16. What's inside being squared to the x? Negative 3. It's right here. If you show your work, it should be really easy. X minus 3 squared. Minus 4 times what goes inside with the y being squared? Positive 2. If you showed your work, should be pretty easy. Plus 2 equals negative 64 plus 144. That gives you 80. 80 minus 16 is 64. And finally, before you can write this in standard form, what does that have to be equal to? 1. So how do I get it equal to 1? Divide by 64. Okay, when you divide by 64, these are going to be nice numbers that reduce very nicely. Okay, 16 over 64 is going to leave you with x minus 3 squared over 16 over 64 is left with 4 minus y plus 2 squared. 4 over 64 is going to leave you a 16 and equals 1. Now, if you wanted to, or if I asked you to, you could find the center and the vertices and you could sketch. I'm not asking you to here. I just want the standard form. Questions on how I did that? Move it up for some of you guys, sorry. Questions? Okay, I have 3 more, but the last thing we're going to do is I'm going to ask you to first write the equation, or excuse me, I'm sorry, write the slope, or sorry, I shouldn't have said write, I should have said find the slope. Find the slope of the asymptotes of the following. So find the slope of the asymptotes of the following. For example, 5. X squared over 100 minus y squared equals 1. Find the slope of the asymptotes of the following. And the slope of the asymptotes of the following. So, is this already written in standard form? Yes. Best way to find the slope is to draw just a little picture. Okay, so let me show you how to do that. Where would you start? What's the center of this equation? 0, 0. Okay. What's missing from this equation right now? The denominator. Okay. What is this missing denominator? A 1. Okay. So if I was going to move side to side, how far would I move? 10. Square root of this, you'd move 10. I don't really care if you can graph it perfectly. I just want you to put a dot and label it that it's 10 away. Okay, put a dot, label it that it's 10 away. How far would you move up and down? 1. Put a dot, label it, it's 1 away. Then we're going to draw that box. Okay, draw your asymptotes through it, through the edges. And there's going to be 2. They're going to be exactly perpendicular to each other. Sorry if I didn't draw that perfectly. And then which direction would these be opening? Would they be side to side or up and down? They'd be side to side because it's an X opener. Now, technically, I didn't need all this part, right? I just want to find the slope of the asymptotes. So if I want to find the slope of this one right here. This is at 0, 0. So how do you write, so the slope of something is, what is slope? Rise over run. So rise over run. Let's just say I want to find the slope from 0, 0 to this edge. How much would you have to rise to get from here to here? How much do you go up? Up 1. So do you see why I had you label it? And how far do you run? Up 1 over 10. That's exactly why I had you write those. Now, how would you find the opposite one? I'll darken it in. I'll make it another color for you. This color. This orange color. Okay. If I want to find the slope of the other one, m equals, again, rise over run. If I wanted to go from 0, 0 to this edge, how much would I go up? Up 1. How far do we go over? Left 10. So if you're going left 10, what is that? Negative 10. Do you notice how these are exactly the same? They're always going to be that way. You really don't have to do the second one. You can just say it's always going to be plus or minus rise over run. Now, there's an even simpler way to do this, though. Okay? I'm going to give you a little formula here. Slope of asymptotes. Slope of asymptotes is equal to square root of, which one tells you the rise? Is it the x denominator or the y denominator? The y denominator, square root of the y denominator divided by square root of the x denominator. And it always works. So really, you don't have to do this whole drawing, okay? You can just look at this, and once it's in standard form, you can write slope of asymptotes. Sorry, you also have to write plus or minus in front. Plus or minus square root of the y denominator, which in this case was 1, square root of the x denominator, which was 10. Okay? This is going to be a very helpful formula for you to use. Yes? M stands for slope. In y equals mx plus b, M stands for slope. Okay? So you don't really have to draw the whole thing if you memorize this. Okay? And then the last thing I'm going to ask you to do is write the equation of the asymptotes. Write the equation of the asymptotes. What's the difference between the slope of them and the equation of them? How do you write the equation of a line? It's written in y equals what? mx plus b form. The only thing different about finding the equation is you have to find the y-intercept, but I promise you all of them are going to cross right here. So what's their y-intercept going to be? 0. So it's going to be something plus 0. So basically, you don't have to write it. All you're going to have to do is write y equals, you're going to have to put in a plus or minus, and you're going to have to fill in the slope. But you can get the slope from this equation. Okay? So keep this in mind. We are going to be using this in just a second. Okay, when I give you the equation of, remember 6, x squared over 144 minus y squared over 25 equals 1. Now, this is only going to work, this shortcut is only going to work if you have a 0, 0 center. Does this have a 0, 0 center? Yes. So to write the equation, the asymptotes, you just put in y equals, you're going to put in a plus or minus, put your x, Leave space for the slope. Okay, remember I just told you slope of the asymptotes, square root of the y denominator. So which is the y denominator? What's its square root? Excuse me. 5 over, what's the square root of the x denominator? 12. This is your answer. That is the equation of the asymptotes. So the only difference here is if I just ask for the slope, you write m equals plus or minus. If I ask for the equation, you have to put in a y and an x. But that's it. Questions on how I did that? Okay, I'm going to give you one more and then we'll be done. Number 7. Again, I want you to write the equation of the asymptotes of y over 9 quantity squared minus x over 7 squared equals 1. Y over 9 squared minus x over 7 squared equals 1. Excuse me. What's wrong with the way this is written right now? It's not quite in standard form, right? To get it in standard form, you just have to take out the parentheses. So y squared just becomes y squared over, what's 9 squared? Not the square root of it, but 9 squared is 81. Minus, take out these parentheses, x squared over what's 7 squared? 49 equals 1. Then again, I just want to write the slope of the asymptotes. You put in y equals, put in plus or minus, something with an x, and find the slope. Square root of the y denominator is what? What's the square root of the y denominator? 9. Okay, it's first. So make sure that you're paying attention to which one is x, which one is y. Square root of the y denominator is going to be 9. Okay, so 9 is in your numerator. Over square root of x denominator is 7. That is your equation. Sorry, that should have been green. That's your answer. Okay. Homework is going to be worksheet 6. You are doing all of them. So numbers 1 through 26. Okay? Nope, you're doing all of them because these are really important and they're pretty heavy on your test. Okay? You guys are going to turn this in tomorrow. I promise that you will be turning it in. Okay? For sure. And does anyone have questions? You have a little time to work on this right now, so I would take advantage of it. You also have a quiz that will cover everything tomorrow. Okay? It's going to cover all the different shapes.